Hey, good morning, everyone.
Good morning.
So I feel like I'm back to myself today, which would be good. I should be able to stay on track. We have an exam that is scheduled for Tuesday, right? Let me get back to this. Here we go. Tuesday, October 5th, which means that we're going to talk about some material today. And then I'm going to provide you a review. I've already put it together. I'll send it to you after we finish the material for today. And then we can talk about the review. And then at some point, I will send you all the solutions to the review this weekend. All right. So last class, I talked a whole lot about nothing, I think. I made some progress, but I didn't get anywhere meaningful in terms of us doing problems. I tried to establish some ideas in terms of quadratic functions and what they are. So let's just recap real quick what I did say that was important. We were talking about parabolas, right, or quadratic functions. Let me bring up, I have one here. You know what, I'll just use this one again. So all quadratic functions look like this. So all quadratic functions look like this, which is a parabola. They can open up or they can open down. You can move them up, down, left, right, okay? All of these are parabolas, all right? And so we want to have the ability that if somebody gives us the equation of a parabola, that we can graph it, all right? That's our goal today, is can we graph one of these if someone gives us the actual function? So we talked about that when you have a parabola, it could be possible that it never touches the x-axis, right? Like this example right here, it's not touching the x-axis at all, right? So here we have no x-intercepts at all. Or it could, if you moved it just right, it could touch the x-axis at exactly 1 point, right? So we would have one x-intercept in this case. Or if you move it like this, it could have two x-intercepts. So with all parabolas, regardless of whether or not they open up or down, you're either going to have no x-intercepts, one x-intercept, or two x-intercepts. It's not possible to have more than two for a parabola, for a quadratic function. Also, they will all of them, no matter what, they will hit the y-axis. Okay, the y-axis I'm talking about here. Every parabola can only hit the y-axis once, but it has to hit once. It can't, it's impossible for it to not hit. Even if I try and change it to make it like really narrow, right? If I make it a really, really narrow parabola, it may look like it doesn't hit, but if you kind of zoom out far enough and go up far enough, you can see that eventually the right side of it did cross through the y-axis. Do y'all see that? Yes? Yes. So we wanted to be able to sketch, right? And this is what we started to talk about last time at the very end. So how do you sketch it? At the end of the day, how do you sketch a quadratic function? So if we're given a quadratic function, all quadratics will look like this. First thing we're going to do is determine if it opens up or down. Now, I don't remember, did I tell you how to determine how it opens up or down? Did I say it? I'm seeing some yeses. What do you look at to determine if it opens up or down?
Whether A is negative or positive.
That's right. So you look at the number in front of x squared. It will open up if A is positive. It will open down if A is negative. So it's a very simple thing to check to see what the parabola does in terms of opening up or down. The second thing we do is find the vertex of the parabola. Now, we talked about what the vertex is a little bit. Let me Get this back here. Let me zoom in on this. So when you're given a parabola, if it opens up, the vertex will always be the point. Let me see, this point here. That point right there will always be the vertex. It's in this case, because the parabola opens up, it's the lowest point on the graph. If I move it, up, down, left, right, the vertex is always that lowest point. Even if I flip it over, right, and I make my parabola open down, now it's not the lowest point, but it's the highest point on the graph. In either case, though, whether it be the lowest or highest point, we would like to be able to find it. And that point is called the vertex. And there is a formula to find the vertex. All you have to do is take some of the numbers here, compute this new number h, and then you compute this number k, and that will give you the actual point. And we'll do an example. I'm just giving you the steps here. After that, we'll do a quick sketch. This will help us determine how many x-intercepts we have. And then step 4, this in blue here, this was going to be the part that sucks, is we'll find x-intercepts if we have any by setting the function equal to 0. And then we will find the y-intercept we should have by plugging 0 into the function, and then we will sketch it. Sketch the final graph. So I think we can take this and let me zoom out just a little bit here. I'm going to copy this and I'm going to bring it with us. I'm going to make it small. Okay. I don't know if you'll be able to see it when I'm doing the problems here, but at least I'll have it up on the page. So here we go. You ready for our first example? Sketching a quadratic. Let's sketch f of x equals x squared plus 2x. Let's go with minus 8. First thing I'm going to notice on this is that it is a quadratic function. I know that because the highest power of x I see is 2, right? So it's quadratic. Next thing I'm going to do is I'm going to identify the numbers in front of things. So I have a 1 in front of the x squared. I have a positive 2 here. I have a negative 8 here. So that gives us our A, our B, and our C. And I forgot to put the instructions here. Try to make these a little bit bigger. Here we go. Hopefully that's good enough for you to see. So A for us here is 1. It's the number in front of x squared. B for us is 2. And the C, be careful, is negative 8, not positive 8, but negative 8. So we have found the different pieces of the quadratic function. And now we move on to the steps. So the first step is to determine if this thing opens up or down. So what do y'all think? Up or down?
Up.
Up, right? This thing opens up. I'm going to just draw a quick little picture. It opens up like this. And the reason I know that is because A is 1, right? Which is a positive number. It's bigger than 0. So I know my parabola looks like this, which means that it has a lowest point, right? A lowest point on the graph. Let's go find that lowest point. That's called the vertex. To do that, I have to calculate 2 things, h and k. So h, the way you get h is you calculate negative b over 2a. And you probably aren't very interested in knowing where this formula comes from, but I will tell you that it comes from calculus. In a calculus class, we can prove that this is true. Here, we're just going to believe it and take it on faith and just move on. But if you're just curious where it came from, it's calculus. So I'm going to take negative b and divide it by 2a. Be real careful here. Negative b means the opposite of b. So our b is 2, right? So the opposite of positive 2 is negative 2. So I'm going to put negative 2 on top over 2 times a, and a for us is 1, so 2 times 1. So this is negative 2 divided by 2, which gives us negative 1. That's what h is. Now, to get k, according to the formula here, what we need to do is we need to take the function and plug h into it. So we need to take the function and plug the answer we just got into this function. That means replace all the x's with -1s. So be careful here because you're going to put -1 and you're going to square it first. So it has to be in parentheses squared plus 2 times -1 minus 8. When you square -1, you get 1. 2 times -1 gives you -2, and then -8. And I believe on that, we're going to get -9. Understand? It's clear. Any questions?
I have a question.
Yes.
So then it was about for the first part. So we know it opens if it's positive, and we got that from the first number that's
Yes.
in the formula. Okay.
The A. It's the A that tells us. So
Okay.
this is A, right?
Yeah.
And that number is bigger than 0. Had that been -1, then it opens down.
Downward. Okay.
Yeah. If it was 4, it opened up. If it's -4, it opened down, right?
Do we not need to multiply the -8 by the -1 to make it a positive?
-8 times -1. Where? Here? Where are we talking?
Because for h, if it was a -2 divided by 2, then you get -1. So then for the actual function, the -1 times -8, wouldn't that be a positive 8?
Hold on.
But I don't think we're multiplying the -1 by the -8.
Are you
It's
talking about
like
right here?
Yes.
Oh, yeah. Okay, I see what you're saying. Well, look it up here in the original function, right? You have multiplication between the 2 and the x, right? That's this multiplication between the 2 and the -1. Do you see that?
Okay.
And
Yeah.
then this is subtraction. So we are subtracting, so we are going to subtract the 8. I think what you're thinking is this is -1 times -8, right?
Mhm.
Yeah, so you have to go back up here and realize that there's not multiplication happening here. If there was, we would have to have parentheses here. And then these would all three be multiplied together. But because there's no parentheses, it's subtraction.
All right.
Is that okay? Good. Okay, so we have the vertex, right? And the vertex is a point. So I'm actually going to write this answer we got down as a point. We got -1, and then we got -9. This is a point on our graph. Now, is that point the highest point or the lowest point? Which way is this graph open again?
It would be the lowest point, wouldn't it?
It'd be the lowest point on the graph.
Yeah.
So we can say that right now. We can say that this is the lowest point on the graph, right? So step 3 is the step that is, I think I may have mentioned this last time. If I didn't, I'm sorry. Step 3 is a step that I usually do, but you know, if you go to a tutor or look in a book or something, most books and tutors don't do this step. Okay, let's do it and I'll show you why I do it. So I'm going to do a very quick sketch. This is not my final answer. It's just to figure something out. So I know that my graph, when I graph this, my vertex is -1, -9. If I go plot that point, that means I go to the left 1, down 9. Agreed? Left 1, down 9. Now I'm not even going to care about how far I go. I just know I go left and down. So my vertex is somewhere down there. Do you agree? Now, which way does the parabola open? Up, right? So my parabola is going to go look like this, something like this, right? What you can tell me now is how many x-intercepts you have, right? How many do you have?
2.
2, right? 2. What if this parabola opened down? How many would you have had?
None.
None, right? Step 4, look at step 4 of the process. I told you step 4 is the hardest step, all right? But step 3 tells you whether or not you need to do step 4. See, because if this had opened down, we would have no x-intercepts and you would skip step 4. I'll do an example like that, but I'm just trying to illustrate why this step is important. We don't want to do work that's not necessary. So step 3 gives us a quick way of telling us whether or not we need to do step 4. So this means to us, we have 2 x-intercepts. We have 2 x-intercepts. Remember, you can either have none, 1, or 2. We have 2 here. And that means I must do step 4. Does that make sense to you? Why I'm doing it? Any questions?
So we're doing it because it's a positive number? Or is it
Doing
another-
what?
The step 4?
I'm doing step 4 because I have 2
Two.
x-intercepts on the graph. If I have 2, I will have to do step 4. If I have none, I will not do step 4.
Oh, okay.
If I have 1, I will not do step 4. All right. You'll see. I'll do an example. The only time you will do step 4 is if you have 2. All right. The only time you'll do is if you have 2. So let's keep going. We have to do step 4. So now I need the x-intercepts. To do this, according to the steps, I must set the function equal to 0, right? In yellow over there. So that means I'm going to take my quadratic function, which was x squared minus, no, plus 2x minus 8, right? That's what it was, and set it equal to 0. Take the function, set it equal to 0. This is a quadratic equation. And when it comes to quadratic equations, there are 2 ways to solve them. The first way is factoring. The second way is using the quadratic formula. Now, today we are just going to focus on things that can factor. And on your test, it'll just be things that factor. Okay. Next class, we'll do things that we need the quadratic formula for. I don't want to overwhelm. Well, I don't want to have so much material today that would be on the test that it would be too much. So I'm just kind of keeping the problems limited today, that when we get to this step, we should be able to factor it. So the way we factor this, and this goes back to the beginning of this class, right? How do you factor this? You multiply those 2 numbers together. Does this look familiar? No? You need to find 2 numbers that multiply to be -8, but add up to be this number 2. So can somebody tell me 2 numbers that multiply to be -8, but add up to be 2? 2 numbers.
2
times -2.
4 and -2, is that what you said? 4 and -2? Do these 2 numbers multiply to be -8? Yes.
Yes.
Do they add up to be +2? Yes. Right? So what that means is you can take this and you can factor it into, you're going to put an x and then you're going to put these 2 numbers, +4 and then x and -2. Now, if you don't believe that's true, that it breaks down like that, then what we could do to convince you is to actually multiply this out. If you multiply it, you'll get x squared. You get -2x. You get +4x. And then you get -8. And when you combine those 2 together, you get x squared plus 2x minus 8, which is exactly what this is, right?
Damn, son.
Pardon me?
Got that shit right. Oh, was I?
Okay, any questions? We'll do another one, okay? But for now, let's continue. Once you have factored it, what you do is you take each factor and you set them each equal to 0. And these are little linear equations. You just have to get x by itself. So you just subtract 4 on both sides, add 2 on both sides, and you get 2 solutions. We have 2 x-intercepts. They should happen at -4 and +2. You got it? I'm going to move on unless there are questions to step 5. Step 5, we need to find the y-intercept, and we're guaranteed that we have 1, okay? And to do it, we do what's in blue here. We just plug 0 into the function. Okay, so this should be pretty easy. We take 0, we replace all of our x's with zeros into the original function, replace the x's with zeros, and what will you get out at the end of this?
-8.
-8, right? -8. In fact, it will always be c. C will always be your y-intercept, but we'll just go ahead and do the math for it there. And now we're ready for step 6, which is to sketch it. So we're ready to put all this together, all right? So here's how I would sketch this. I would draw my x and y axis. I always start with the vertex. So what was our vertex? Was it -1, -4? What was it?
-4,
-9.
2.
Oh,
Oh.
-1, -9 was our vertex, right? -1, -9. So now that means I'm going to go to the left one. There's -1. I'm going to go down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Didn't go quite far enough there. -9. And right there, I'm going to put a point. That is my vertex. That is the lowest point on the parabola. The next thing I'm going to put here, you know what? I'm going to label that -1, -9, so everyone knows what that point is. Next thing I'm going to do is go and do my x-intercepts, which are at -4 and 2 on the x-axis. So on the x-axis, I go to -4, so -2, 3, here's -4. And I go to +2, which is there. And I put 2 points there, 1 here and 1 here. I'll even label those for you, 2, 0, -4, 0. So that, again, everyone's clear what these points are. We have one more point that we can graph, and that's the y-intercept. The y-intercept was -8, wasn't it? So on the y-axis, I'm going to go down 8, which puts me right here. That's the point 0, -8. That's also on my graph. And that's it. That's all I have. That should be enough to draw the parabola. So one thing I recommend you do is wherever the vertex is, don't draw this, or you can draw it maybe with a dotted line. Imagine an imaginary line cutting right through the middle of your graph. When we draw this, your graph should be a mirror image of itself over this line. It should be symmetric. So I'm going to draw a U shape that opens up. It's going to start down here. I'm going to kind of connect these dots together. Kind of missed it there. And then do the same thing on the other side, like that. That is what I'm looking for on the test. I want you to have a final picture where you've labeled your x-intercepts, you labeled your y-intercept, you labeled your vertex. What do you think? Seem reasonable? So let me ask you something. Let's say you're doing a problem, right? Let's say you're working through a problem and you go through all the 6 steps, okay? And you get to the end, you're like, okay, I'm ready. Sorry, you get through the 5 steps, you get to your 6th step and you're ready to graph, okay? Let's say you've gotten to that point. And you start to go put down all of your information. So you go and you draw your X and Y axis. And let's say you say, oh, okay, I figure out that my vertex is right here, okay? That's your vertex, V for vertex. And then you go and you say, oh, I found an x-intercept here and an x-intercept here. And then you say, oh, I found a y-intercept here. Okay. If you imagine again that line going down the center, Do you see something's wrong? Something is wrong, because if I try and do this, I would have something like this, but then over here, it would look like this. And that is not what parabolas look like. They look like reflections of each other over this green line. They're a mirror image. So something is wrong, which means you would need to go back and take a look at your work, make sure you didn't mess up a sign. It's what's the word I'm looking for? It's, if everything looks symmetric, then that means you probably got everything right, okay? But if you mess one little thing up, something is gonna look off, right? Another thing I've seen before is something like this, where a student will go and they'll work through a problem, they'll get, you know, something like this. They'll get an x-intercept here, an x-intercept here, and then they'll get like a vertex over here. And then what they'll do is they'll draw this for me. You know, I mean, it's off, right? Something is wrong. So be looking for those indicators when you're doing your graph. If anything looks off, go back through each step, make sure you got everything right. I guess that's good news and bad news, right? I mean, it's good news because I mean, if it looks right, it probably everything you did was probably right. If it's off, you've got to go figure out where the mistake was. Let's do another one. Sorry, I'm just thinking. So how do y'all want to do this? Do y'all want me to work through this one, or do you want me to let you work through it? What do y'all want to do?
Try work through it.
You want to give you a little time? Okay. I'll give you some time to see how you do with this. I'll give you a warning though. When you get to the vertex, okay, you're going to have fractions, which means that it's okay if you use your calculator for decimals. All right, that's fine. So when you find H, I'm just telling you, when you find H, it's going to be a decimal, a fraction. And so that means you have to plug that into the function. I'm just curious to see how you do with that. If you get hung up on step 2, just move on. Although, well, no, don't, no, you're going to still need it. So see what happens. Let's see. And then what I'll do is I'll put up a little poll, and there's 2 choices on this poll. Choice 1 means you're done. Okay. Don't do anything until you're done. But when you're done, just click choice 1. When you have a picture drawn. All right, let's see how long it takes someone to finish this. And then I'll wait till I get a good group of you that have finished it. Hey, everyone, I think what I'm gonna do is while you're working it, I'm gonna start working it just in silence, and then you can kind of look up and reference mine and see if you're getting the same thing.
Sir, is it okay if I ask you a quick question right now?
Yeah, go ahead. What's up?
Are we supposed to be getting decimal points or do you want fractions?
Decimals will be better because we have to plot these points on a
On the
graph.
graph, right?
Yeah,
Yeah.
so normally I've always told you, stick with the fractions, but once we
Yeah.
start graphing things, the decimals become easier to handle. Good question.
Okay, cool. Thank you.
Okay, I'm at a point where I'm ready to graph it, but I'm gonna wait. There's only 5 out of 22 that have said they've completed it, so we'll go a few more minutes. Okay, I think we should discuss this. There's just about 70% of you are finished. First of all, are there any questions over the work that I put up here?
I have a question.
Yes.
So whenever you had graphed that 2 x-intercept points, that was the 6 and the -3 that we took from?
No, I haven't done my final picture. This step 3, the quick sketch, was just using the fact that I knew the vertex. So I
Okay.
knew I was going to move to the right a little bit, 1.5, and go down. So I
Uh-huh.
went right and down, drew a point.
Yeah, and I got that point. Yeah, the vertex, which is the 1.5. Yeah.
Mhm.
Okay.
And I didn't even like plot it. Notice I wasn't trying to be accurate. I was just trying to figure out where my vertex was, like generally speaking, to the right and down. And then using the fact that it opens up, I knew that if it opened up from this point, that it would have to hit the x-axis in 2 places.
Yeah, that's how my drawing looked. And then I went down, it was 9, was it 19 or 18? Yeah, I went down 18 for the y-intercept. Yeah, I went all the way down 18 dots. Was that correct? Because it's the
Well,
y-axis.
I have not drawn my final picture yet.
Oh, that's right. That's right. I'm sorry.
Yeah.
Yeah.
This I've just done just to get a basic idea of whether or not I had x-intercepts. I'm about to draw it, but I just want to make sure everyone was okay with the first 5
Oh,
steps.
okay.
We're all good? Let me try my best here. I'm gonna try and squeeze it in right here. Here's my graph. So I know I'm gonna have to go down like really far, 20 or so, right?
Yeah.
So watch what I do. All right, this is kind of an important part of this problem. Because I have my vertexes down so far, -20, I'm actually going to count by twos as I go down. So this will be -2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's -20. All right. So instead of counting by ones, I'm counting by twos. That means when I count up, these are going to be by twos. Now, when I go left and right, I do not have to count by twos. I can count by ones or however I want to count. So your up and down scale has to be the same, but your left and right can be different than your up and down. Does that make sense? Okay, so for my x-intercepts at 6 and -3, I'm just going to count by ones. So 1, 2, 3, 4, 5, here's 6. Then 1, 2, 3, I'll just go over here. Okay, so let's go. Let's start with the vertex. I need to go to the right 1.5, 1.5, and down 20.25. So look, we're just going to kind of ballpark this. To the right 1.5 takes me to about right there. And then down 20.25 takes me a little bit past 20. So I'm going to put it right there. Now I'm going to label it. That way you know what the point is, right? You're not trying to guess what it is. That's what it is. Then I'm going to plot my x-intercepts, which are at 6 and -3. So here it's 6, which is the 0.60, and -3, which is right here, -3, 0. I have x-intercepts. And then I have a y-intercept of -18. -18 is right here. I'm also going to draw that vertical line through the middle just to see if my symmetry looks good. And I think this is going to work. This looks pretty evenly spaced. So I'm going to draw the left side of my parabola through those points and just try and make the right side of it match up as best I can. That's it. Any questions? Make sure you label your points on the test, just like I labeled mine. Also, one more thing. Do not draw a V, okay? So if you do this, that's not good. If you do like a V here, like this, with a sharp corner, I have to take off at least a point or two because parabolas are curved. They're always curved. They never have a sharp point on them. So I see students do that. They draw me V's, and that's a different type of function. It's not a quadratic. It's actually an absolute value function, which we haven't studied. So we don't want to confuse the two. It's like, again, remember when I was talking about parabolas, like throwing a ball through the air, right? A ball doesn't go up and back down like that. Like that's not the way it works, right? It goes up, curves through and down. So make sure your drawing looks like a parabola. Okay, I want to do one more and then we're going to talk about the test because I don't have much time. So the last one I'm going to move quickly through. You know what? Hold on. Yeah, we'll do this. I have not given you a single one that opens down yet, right? Everything's opened up. So that we'll save that for next time. All right, so for this one, first step, well, it opens up, right? Because A is 1 again. I've also not done anything other than 1 for A. I will later change A to be something else. But for the test on Tuesday, just expect to see A as 1, all right? All right, so it opens up. Now the second step is the vertex. So I need to find H, which will be -B over 2 times A. So -2 over 2, which is -1. That's nice, no decimal there. K is what we get when we plug -1 into the function, which gives me -1 squared plus 2 times -1 plus 1. Again, be real careful because you're squaring the -1, which gives you +1, then -2 plus 1. What does that turn out to be? What is that? 1 minus 2 plus 1? 0, right? 0. So my vertex is -1, 0. Y'all with me? Third step, quick sketch. So I need to go to my vertex. Where's my vertex? Just to the left a little bit, right? That's it. I just move to the left. I don't go up or down, do I? I don't go up or down. So I just have a point here. And which way does my parabola open? Goes up,
Downward.
right?
Oh,
Upward, right? Goes up because A is 1. What does that tell you? How many x-intercepts do you have?
Would X just be, or would that just be X?
Yeah, that we just have one x-intercept, don't we? We have one x-intercept, and it happens to be the vertex. The vertex is the x-intercept. This is the first time this has happened. Do y'all see this? We have one x-intercept. And what that tells me is I'm going to skip step 4. I'm skipping step 4 because I don't need to go find the x-intercepts. I have the only one that exists. It's right here. That's good. So step 4, we're skipping. Step 5, I do need the y-intercept. So to get the y-intercept, I plug 0 into the function. And if you plug 0 into that, you should get 1. So that means I'm ready to sketch. I can actually get it right here. I don't need any more room than this. Start with my vertex. My vertex, I move to the left 1, and I don't go anywhere. So I'm just going to put a point right here. That is the point -1, 0, right? I also have the y-intercept, which is 1. That's here. That's the point 0, 1. And that's all I have, right? That's it. That's all I have. So I draw my little symmetry line through the middle of the vertex, and then I just draw a parabola that goes out the right through that point and just make the other side look kind of the same. I keep missing these points. That's it. So when we have one x-intercept, it's actually a little faster to graph it because we don't have to do step 4. Questions on that? Okay, let's take a look at the review. I'm going to send it to you through email. Should I just do that now? I'll send it to you now. That way you have it. And if you want to open it, you can look at it with me. Remember, you know, the same expectations for this test as the last one. Make sure you come to class, your camera's ready to be set up, all that stuff, right? You're gonna have to send me your test just like we did the first exam. So hopefully it'll go a little bit faster this next time. Exam 2 review. Put on here 13, 14, exam 2 review. Attached. So let me go grab it. Let me see where I put it. Uh-oh, where am I? I'm in the wrong place, I think. There it is. Okay, I just sent it through email. And I'm going to open it up here so we can take a look at it. All right. So your test will be similar to this review. This review has all the concepts that you need to know. So the first question has two parts to it. It asks you to sketch these lines. So you have to determine how you want to do that. Remember, to sketch a line, there's two different ways, right? There's the intercept method, and then there's the slope intercept method. I do not care, but these two are probably best suited for what method? Can you all tell? The intercept or the point intercept? Or
The slope
sorry,
intercept.
slope intercept is what I meant. Good, Emily. Because these are solved for y, aren't they? So these look like y equals mx plus b. So you should be able to do the slope intercept form for these. Now for number 2, you have to sketch these lines, and these are not solved for y. So the other method might be better, the intercept method. Okay, so first 2 problems off the bat, be ready to sketch lines. Does that seem reasonable? Go back and look at your homework. Go back and look at what we've done. Okay. Number 3, graph both of these lines on the same graph. Y equals -2 and x is 4. Someone want to help us out here and tell us what we're looking at here? What is this?
Wouldn't be the
If you
slope.
had 0 or vertical.
Yeah,
slope,
we have vertical and horizontal lines here. Because it's y equals a number, there's no x's in the first equation, then x equals a number, which means there's no y's in the equation. So these are vertical and horizontal lines. I'm not going to tell you which is which. Go back and review if you need to. So I just want you to graph both of those together on the same graph. Number 4, I want you to find the slope of a line through 2 points. So we didn't hit on this too hard, but it's in the review, so it means it can be on the test. You need to remember that the slope is equal to rise over run, which is equal to the difference in the 2 y coordinates divided by the difference in the 2 x coordinates. So all you do here is you just label one of these points x1, y1, the other one x2, y2. And then you run this formula and you're going to get a number. That'll be the slope of the line. So your answer for this, I'm not asking you to draw a picture or anything, just tell me what the slope of the line is that goes through those 2 points. Then on number 5, I say, okay, using your answer from number 4, what would the slope of a line that is perpendicular to this line be? I'm not going to tell you. You need to go back and take a look. What does it mean for a line to be perpendicular? How are the slopes related to one another? I'll let you review, right? That's what reviewing is about. Okay. Number 6, I give you a function and I ask you to evaluate the function at a few different values. What's f of 3? What's f of -2? What's f of 0? And then I ask you, for what value of x would f of x be 17? We did all this, okay? So go back and review. This number 5, I don't know why I didn't delete out of here. That's not supposed to be there. Number 7, I give you a graph, okay? I give you a graph, and then I ask you to answer some questions about that graph. This is all about reading values off of a picture. So again, we did this. Go back and review. 8 is going to be a word problem. Okay, so my water bill charges $25 a month for services and 3 cents for every gallon of water used. Answer these questions. Come up with an equation, then answer the questions. Again, we did this, all right? And then the last 2 are sketching. Now, let's change the 10th one. I wasn't sure how far we were going to get today. Let's change this one, okay, because we didn't do anything with a negative in front and a 2. So how about this? Instead of that, let's keep it with a 1 in front. So x squared, let's go plus 7x plus 6. So 2 sketching problems. And if you want, just for practice, I'll give you another one that you can do. Oops, x squared. There's another one if you want to practice another one. That one's kind of interesting. Does that all seem reasonable? Does that seem like stuff we've seen? Stuff we've done over the past few weeks? All right. Well, in that case, I really don't have anything else for you. I'll hang out if you have questions or want to ask something specific on the review or anything we covered this time or any of the other classes.
Will we be able to have a function sheet on this test?
Okay. I was wondering if someone was going to ask. So on the first test, we did, right? I can't remember. We had, everyone had a little, you were allowed to have a little like cheat sheet, reference sheet. Yeah, we'll do that for this one too.
Okay, thank you.
But remember, you can't have worked out problems on it, right? So it'd just be formulas and steps. So you know the 6 steps I gave you to sketch a quadratic? You are allowed to have that, okay? What you can't do is just work out a problem and have it all worked out in front of you, all right?
Sounds good.
So one, just to be official, one standard 8.5 by 11 sheet of paper. I know this is not 8.5 by 11, but a standard 8.5 by 11 sheet of paper, front and back. You can put any steps, formulas, procedures, anything that you think will help you. But just don't work any problems out. You will turn that in with the test.
Can I just use like the note card that I have?
That's fine. The maximum size you can have is 8.5 by 11.
Have a good weekend.
You too.
I have a question.
Yes.
Do we have to use a proper graph sheet, or we can use normal like A4 paper?
Yeah, you can use regular paper for your pictures. Just when, that's why it's important for you to label your graph. So when you're doing your work, right, when you draw that picture, that final picture for me, you know, if you don't have graph paper, right, if you only have line paper, it might look something like this. That's why it's important for you to just make sure you label your points.
Okay.
If you have graph paper, great, you can use it, but you don't have to have it.
Okay.
Will the test be 10 questions?
I would expect it to be somewhere around 10 questions. Yeah.
Yes, sir. Thank you.
With this class, we don't have a ton of time, right? We get into the class, we start, it takes us about 10, 15 minutes to get started on the test. That really only leaves us about an hour to do 10 questions. And some of these, like I just did this problem, right? And I had y'all graphing and it took, you know, a lot of students at least 10 to 15 minutes to do that. So,
Yeah.
you know, and there's 10 problems. So, okay.
Thank you.
Yep. Anything else?
Bye.
Thank you.
Bye. Have a good weekend.
You too.
Oh.
Wait.